the terms involved in spherical mirrors. So what are the terms we use? What are the terms we use in spherical mirrors? Okay, so to know that, let us take first a concave mirror. We'll take a concave mirror. What are the terms we use in concave mirror? So this is a concave mirror, right? And it is silvering. Just you should not forget this. Silvering should be done properly, otherwise it will not represent any mirror. Yes, so it's a concave mirror. And the first term, what is the term involved in concave mirror? So first, what is here? Terms involved. Terms involved or terms used. Terms used in concave mirror or spherical mirrors. First we are observing the concave mirror. Okay, so first one, if it is the mirror, yes, the middle point or the midpoint of the mirror or geometrical center of the mirror is called pole, which is represented by P. The midpoint of the mirror or geometrical center of the mirror is called as a pole, which is represented by P. Next, the center of curvature. Center of curvature. Then how can we represent the center of curvature? Just now I have explained, right? So the center of the sphere from which this curve is obtained, that means this mirror is obtained. Yes, so that is called center of curvature. Simply the term itself indicates it. The term itself explains center of this curve. Center of this curve or center of this curvature. It is a curve. For this curve, this is a center. Yes, if you extend this, it makes a circle or it makes a sphere. For this sphere, there will be a center, right? That center will be the center of curvature for this mirror. Is it clear? So this is center of curvature. Center of curvature. So let us indicate here center of curvature C. Then next, let us join these 2 points. Let us join these 2 points by a line. Just a line, an imaginary line passing through, pole and center of curvature is called principal axis. Principal axis. Not principal axis, principal axis. Simply main axis. Main axis. Right? Principal means main. Principal means that is another one. That means rule. Okay. So principal here. Okay. PAL, principal, not principal. Right? So the principal axis, the line or the imaginary line which is passing through the pole and center of curvature is called principal axis. Then let us take here. Center of curvature is here and pole is here. The distance between center of curvature and pole is called radius of curvature or radius of curvature. As I already told you, if it is a circle, yes, then from center to any point on a circle, yes, that represents radius of that circle. But here it is just a curve. Radius of this curvature. This is the center of this curvature. It is the radius of this curvature. Is it clear about it? Yes. Next, if we place any object, if we place an object here, if we place an object O dash, if we place an object O dash, then from the pole to object there is some distance. From pole to object there is some distance. That means the distance between pole of the mirror and object is called as object distance. The distance between pole or mirror also we can say. The distance between mirror and object is called object distance, which is represented by U. If it forms an image, yes, then there will be an image distance. The distance between mirror and image is called as image distance, right? And there are only two terms remain in this, that is focus and focal length, principal focus and focal length. Let us discuss what is that. Let us learn what is that. We have taken a concave mirror and we placed it in sunlight. We placed it in sunlight or near a window we placed, and through the window we are able to see a tree. We are able to see a tree just far away from the window. Yes, so there is a tree, and we placed a concave mirror here, and then this concave mirror takes the image of that tree, and then it reflects back. It forms an image. Just if you place a screen here, then it forms its image on the screen. Yes, if you move this screen here and there, then somewhere in front of the concave mirror, it forms a clear image. That means there it is focusing. Yes, so whatever the rays coming from the tree are falling on the concave mirror, and that concave mirror is reflecting those rays and focusing on the screen. So where it focuses perfectly, there it forms a perfect image. Perfect and bright image. Yes, so here what is happening, from the far away distance or from some distance, okay, from some distance, the rays are falling on the mirror, and those are reflecting back, and all of those mirrors are converging at a point. That point is called as a focus of that mirror or concave mirror. Yes, that's it. And here let us see. So whenever the object is far away from the mirror, yes, all the rays coming from that object are parallel to the principal axis, just like the sun. Yes, sunlight. Sun is far away from us. Yes, so it emits the sun rays which are parallel to each other, and you can do the same activity with sun rays also. Yes, and if you place the concave mirror in sunlight, and it captures the sun rays and it focuses its bright spot on the screen or paper, right? Yes, just like this we have to place a concave mirror. Yes, and there is a tree, and screen should be placed here, screen should be moved here and there to get a bright image. Where we get the bright image, and that point will be the focus of that concave mirror, focus or focal point or principal focus, we can say. Yes, and the distance between this point, focal point, and the mirror is called as a focal length, right? Let us see that. Whenever the parallel rays are falling on this mirror, so whenever we are placing an object in front of this, yes, we are talking about only the parallel rays. When the object is far away from the mirror, definitely it gives parallel rays. Definitely it gives a parallel rays, and the image will be formed at focus itself, right? So whenever all the rays from the distant object, means the object is at infinity distance, that means the object is far away from the mirror, and it gives all the parallel rays. Parallel rays means all these rays are parallel to principal axis. And a ray also will be passed through this principal axis. Along the principal axis also there will be a ray. That means each and every ray is parallel to principal axis, right? And after reflection, they will form an image at focus. Yes, then how can we draw the reflected ray? Here this is an incident ray, all these rays are incident rays. Then how can we draw the reflected ray? So for that we can draw normals for this point. For this point normal, how can we draw the normal? From this point there is an incident ray, right? So from this point to this point, yes, the center of curvature to this point itself acts as a normal. Let us draw this. It is the normal, and next from this point it is a normal, and from this point it is a normal, and from this point it is a normal, right? So here this is angle of incidence, right? It is angle of incidence, and here it is angle of incidence, and here it is angle of incidence, and here also it is the angle of incidence. Yes, and with the same angle we have to draw the reflected rays. We have to draw the reflected ray in this manner. This is reflected ray. Yes, these directions, this indication is must, should not forget this. So this is incident ray, it is reflected ray. Reflected ray has striken this principal axis at this point. And next, another reflected ray of this second incident ray, right? Next, reflected ray of this incident ray here, and next here. So all these reflected rays are intersecting at a point. So here we can see the perfect image of the sun if it is placed in sunlight. Yes, but if it is placed in the window, in front of a window, so here the image will be formed, and the inverted image will be formed, upside down image will be formed here. Then why the image is formed here only? Why the image is not formed here? Why the perfect image is not formed here? When you move it away from and nearer to the mirror, the image will be blurred, because all the rays are converging at this particular point. That is why the bright image will be formed at this particular point. Yes, so here and here all the rays are not converging perfectly, so that is why we cannot see this bright image at this point and at this point. Yes, that is the reason it is called a focus. So how can we define focal point or focus? Here, whenever the parallel rays are falling on the mirror, whenever the rays which are parallel to the principal axis are falling on the mirror, after reflection they converge to a point. That point is called as a focus or principal focus or focal point, right? And this focal point is represented by capital F, and the distance between this focal point and pole is called focal length, right? So now how many points, how many terms we got? Yes, I forgot one more point, one more term, that is aperture of the mirror. Yes, so the diameter of the reflecting surface, of the mirror is called as a aperture. Yes, so this is totally this diameter of the reflecting surface, how much light it can how much light it can be focused. So here this much is the diameter where the light can be fallen. So diameter of the mirror where the light can be fallen, or from where the light can be reflected. So that is the aperture of the mirror. Okay, let us see all these terms in a simple manner in a single diagram. Okay, let us take the concave mirror, silvering. This is must, you shouldn't forget this. Pole, the geometrical center of the mirror, pole, and next the center of the sphere from which this mirror is obtained, that is the point center of curvature C, and the line joining pole and center of curvature, principal axis, the line joining pole and center of curvature, principal axis, and the distance between pole and center of curvature is R, radius of curvature. Yes, then here at this point we can find focal point or principal focus, where all the parallel rays, reflected parallel rays, will meet together. That point, focus or principal focus or focal point, Yes, the distance between focal point and pole is called focal length, and here the diameter of, from here to here, the diameter of the reflecting surface of the mirror is called as aperture of the mirror. And now here let us find out the relation between R and F, the relation between R and F, relation between radius of curvature and focal length. And you observe here, if it is the radius of curvature, in this it is actually half. In the radius of curvature, the focal length is half. That means F equals to R by 2. F equals to R by 2. That means focal length is half the radius of curvature, and it can be said in another manner, that is R equals to 2 into F. That means radius of curvature is twice the focal length. This is the relation. You must remember this. You shouldn't forget this. Is it clear? Okay. And so convex mirror, the midpoint or the geometrical center of the mirror is pole, and the center of the sphere from which the mirror is obtained, center of curvature. Yes, and you have to forget that. You shouldn't forget that. Here, this is the sphere we have to take here. Yes, so the center will be here. Center of curvature for the convex mirror will be here. Yes, so let us join the line which is passing through pole and center of curvature. The line passing through, or the line joining pole and center of curvature, is called as a principal axis. Pole, center of curvature, principal axis, and next here it will be focus. Yes, so let us see that whenever you place it in sunlight, or whenever you place it in front of a window, yes, here the parallel rays coming from the object, they hit this point, they hit the mirror. So these are all the incident rays. But here in the previous case they converged. In case of a concave mirror, they converged to a point, and we call that point as a focal point. But here in this case, they do not converge. These parallel rays do not converge to a point. They diverge from the mirror. That means if these are the parallel rays, yes, in the previous case what happened? They converge to a point. Converged means అంటే అన్ని ఒక దగ్గరికి వచ్చేసాయని. ఓకే, దీనిపైన పడిన రేస్ అన్ని ఒకే పాయింట్ దగ్గరికి వచ్చేసాయి, కన్వర్జ్ అయ్యాయి. ఎస్, బట్ ఈ కేసులో ఏమవుతుంది? దే డు నాట్ కన్వర్జ్ టు ఏ పాయింట్, దే డైవర్జ్ అంటే ఏంటి? ఒకదాని నుంచి ఒకటి దూరం వెళ్ళిపోతాయి. ఎస్, దే డు నాట్ కన్వర్జ్, దే డైవర్జ్ ఫ్రమ్ ద మిర్రర్. Yes, then how the image will be formed? If all the rays are converging to a point, if all the rays meet at a point, then the bright image will be formed. But in case of this convex mirror, those are not converging to a point. Yes, they are diverging, I am saying. Then how the image will be formed? Yes, the image will be formed inside the mirror. That means if this is the incident ray, then let us draw the normal for this. This is the normal, and let us draw the normal at this point. It is the normal, and it is the normal, and here it is the normal. One more time I am saying that from the center of curvature to any point on the mirror, a line drawn from the center of curvature to any point on the mirror, that acts as a normal. Yes, so here this is the angle of incidence, and angle of reflection will be here we have to take, and it should be drawn in this manner. Yes, it is the divergent ray, reflected ray. Next, for this like this. It is reflected ray, and for this it is the reflected ray, and for this it is the reflected ray. So here you can see that all these are incident rays, and after reflection what happened there, they are reflecting back. That means those are diverging from the mirror, but if you extrapolate these rays, if you extrapolate the reflected rays, here, if you extrapolate the reflected rays, they meet at a point. If you extrapolate all the reflected rays, they meet at a point on the principal axis inside the mirror, and there the image, that is nothing but the focal point. That is nothing but the focal point of this convex mirror, right? So there the image will be formed, right? So the image will be formed inside the mirror in case of a convex mirror, and the distance between this focal point and this pole is nothing but focal length. And here also the same relation between radius of curvature and focal length, r equals to 2f. Radius of curvature is twice the focal length. Yes, and focal length is half of the radius of curvature. R equals to 2f, or f equals to r by 2, right? So this is about the terms involved and the finding focal point and focal length of convex mirror and concave mirror.